John F. Kennedy says, "Let every nation know, whether it wishes us well or ill, that we shall pay any price, bear any burden, meet any hardship, support any friend, oppose any foe, to assure the survival and the success of liberty."
Hello once again, everybody, and thank you for joining me for another episode of YemmaNation Explores Reading. My name is Mr. Yemma, and I'm an instructional coach in Youngstown City Schools. I've been doing this read-along series with you where I read aloud books from the National Geographic Panorama reading series. I want to welcome my special guest today, my cat Comet. He's probably not going to read aloud to you like my son does, but it looks like he wanted to join me for an episode. The book I'm going to read to you is called Chemistry in the Kitchen. And this book is written for a second grade level. But as always, you do not have to be in second grade to enjoy the read along with us. So thank you for following along, and I hope you enjoy.
Chemistry in the Kitchen by Susan Halko. Say Cheese by Susan Halko. There are many kinds of cheese. In fact, there are hundreds from all around the world. All of these cheeses begin with one ingredient, milk. So how can you start with milk and end up with so many different kinds of cheese? Science can help explain. The milk goes through some big changes, chemical changes. Two ways to change. Matter can come in three different states: solid, liquid, and gas. Take water, for example. It can be a liquid, drink, a solid, ice, and a gas, water vapor. It can change from solid to liquid to gas again and again. When water changes from one state to another, it goes through a physical change. But cheese is different. It's not just solid milk. It's brand new matter, and it cannot be changed back into milk. This means that chemical changes are happening to the cheese. Let's find out what causes these changes. From liquid to solid. First, cheese makers turn milk into a solid. Then they add bacteria. Bacteria are tiny living things that you see with a microscope. The milk and bacteria are stirred and heated. Heat makes the bacteria become more active. They turn the sugar in the milk into lactic acid. This changes the milk into a solid, like yogurt. That's a chemical change. Next, cheese makers add rennet. Rennet is an enzyme found in cows' stomachs. It helps speed up the chemical change. It makes the milk thicker, like pudding. Curds and whey. The solid milk, or curd, sits in a watery liquid called whey. The whey is separated from the curds. Some cheese curds are packed into molds and salted. Others are heated and stirred again. Cheddar the cheese. Other cheeses, such as cheddar, are cut into slabs. They are stacked on top of each other and flipped. This helps drain more whey. The slabs become much thinner. They are cut into small pieces and salted. This stacking, flipping, and cutting is called cheddaring. Aging. Cheeses are stored in rooms with controlled temperatures and moisture. Aging can take weeks, months, or even years. The bacteria are still alive in the cheese. As cheese ages, the bacteria keep causing chemical changes. These change the flavor and texture of the cheese. The more cheese ages, the sharper it tastes. Few steps, many cheeses. All cheeses follow the same basic steps, but changes can be made to make different cheeses. For example, thousands of different bacteria can be added. Cheese makers decide which ones to use. They also decide how much whey to drain, what temperatures to use, or whether or not to reheat the curds. The milk makes a big difference too. Different breeds of cow make milk with different qualities. Milk from goats, sheep, and even buffalo can also be used. Let's check out what changes are used to make a few famous cheeses. Stinky cheese. Have you ever smelled stinky cheese? The smell can knock your socks off. That's because some bacteria in stinky cheeses are the same bacteria found in human sweat. PU! But some stinky cheeses, such as Limburger, taste very mild. Holy bacteria! What makes the holes in Swiss cheese? Gassy bacteria. A few weeks after the cheese is made, it is put in a warm room. The warm bacteria make gas bubbles, another chemical change. Swiss cheese curves around the gas bubbles. This makes the holes. Moldy blue. What makes blue cheese blue? Mold. It's added to the milk. As the cheese cools, the mold reacts to oxygen in the air. The outside of the cheese turns blue. That's a chemical change. But how do the blue lines get inside? Cheese makers poke holes in the cheese. Oxygen goes inside and makes the mold turn blue. That's another chemical change. As you can see, physical and chemical changes are part of the cheese making process. Changes for breakfast. Chemical and physical changes happen all the time, even during breakfast. Let's take a look at a special breakfast menu. It will help you learn about physical and chemical changes that happen in different foods. But first, review these hints about physical and chemical changes. Some signs that a chemical change has happened. Light or heat is given off, the color changes, bubbling or gas forms, the odor or smell changes, a solid forms, the change cannot be reversed. Some signs that a physical change has happened. The substance is the same, only its properties have changed. Good morning. Veggie omelets. Melting butter in a skillet. Physical change. The butter changes from a solid to a liquid, but it is still the same substance. Shredding cheese. Physical change. The cheese changes its form, but it's still made of the same stuff. Chopping the veggies. Physical change. The physical properties of the vegetables change. They are just smaller pieces. No new substance was made. Cooking the eggs. Chemical change. The eggs turn from liquid to solid. You can't reverse this change. Pancakes. Heating the batter. Chemical change. The batter changes from a liquid to a solid pancake. You cannot change the pancakes back into pancake batter. Side orders. Toast. Chemical change. Heat makes the bread turn brown and crispy. Cold cereal. Physical change. Adding milk to cereal makes it mushy, but it doesn't make it into a new substance.
The end. I hope you guys enjoyed this book about chemistry in the kitchen, and I want to thank you once again for following along with me. I was so excited to read this book out loud to you today because it combines two of my favorite things, science and cooking. If you haven't known me for long, I used to be a science teacher, and it was a job that I absolutely loved and enjoyed. And of course, I love to cook up some good dishes in the kitchen. So with that being said, I'm going to end today's episode. I want you guys to tune in next week. I have a special guest surprise visitor for you. Somebody new is going to read a book out loud to you, and I'm so excited to share that experience with all of you. For now, I'm going to keep it a surprise, but stay tuned next week and join me on another episode of YemmaNation Explores Reading. Thank you. Bye.